Okay, so we're doing rotation. So when doing rotations, use this cheat sheet. Clockwise is this way, it's a negative rotation. Counterclockwise is this way, it's a positive rotation. So this tells you it's going 270 degrees about the origin. That's positive, so it's going to be counterclockwise 270. So the rule is xy to y negative x, right? So if you apply this rule, say you had the point 3,1, and you applied each rule, this would be at -1, 3. This one would be at -3, -1, and this one would be at 1, -3. So we are doing a 270 counterclockwise rotation. It's going to go from xy to y negative x. So each point is going to go from xy to y negative x. You can also do these like Khan Academy. They use like a protractor. I mean, not really like a protractor, but you know, they mark where 270 degrees would be from the origin and from point to point. So, I mean, you could do it that way. So, for example, point R is here. 270 rotation, well, 90 would be about that. 180 would be about that. If we're going counterclockwise, 270 would be something like over here. So you can do it that way. That's the way they do it, but just use the cheat sheet. It helps. It's way easier. So if point R is at -2, 3, it will now be at 3, 2. Because a negative make us a positive. Okay, so point O is at -2, -1. It will then go to -1, 2. Point T is at 7, -2. It will then go to -2, -7. And S is currently at 7, -6. It will then go to -6, -7. And then you just plot each point. So 3, 2, -1, 2, 2, -2, -7, -6, -7. And that's a 270 rotation. You can see it goes from point R to point R, which is 270 degrees right there. So each point is from point to point, it's 270. Okay, so for these, it helps to draw. You can, just draw in Khan Academy. It's going from point C to point C prime over here. So you can tell that is going clockwise. And it looks about 45 degrees. So it would be a -45 degrees because it's clockwise. So for this one, you're rotating it -180, which is clockwise 180, which goes from xy to -x, -y. So we're going now from xy to -x, -y. So just do each point. We have T, O, P. Point T is currently at 6, 0. It then will go to -6, 0. Point O is at -2, -5. It will then go to -x, which would be 2, -5. And then P is currently at -2, 5. Or did I already do that one? Sorry, -2, -5, and that one's at -2, 5. So this one would be at +2, +5. This one would be at 2, -5. And then just plot each point. -6, 0, 2, 5, 2, -5. There it is. That's a 180 degree rotation through the origin. You can tell from point to point. 180, 180, 180, right? It makes a straight line from point to point. So yeah, just apply these rules. Look at the coordinates and apply the rule. And that's how you can do rotations easier. For this one, point Q is here. So from A to A, that would be clockwise, and that would be about almost a straight line. So clockwise is negative. So yeah, about negative 150. And then you do the same thing for this, just use the cheat sheet. Okay, so let's go to the dilations. So dilation, center of dilation is when it should hit from point to point. So if it's going one, if the scale factor is a 1/3, that means it shrinks. If it's less than 1, it shrinks. If it's greater than 1, it stretches. So remember, for center of dilations, it should hit from each point on both triangles, which it does for that one. It's not going to do that for B or C. And that doesn't look like a 1/3 dilation. So I'm going to have to go with A. So it tells you here, what's the center of dilation? Same thing. You want to draw a line. It has to hit from point to point. Doesn't do that for B. Doesn't do that for C. Doesn't do that for A. Does that for D. Hits both points on the triangle, both points on the triangle. So D is the center of dilation. Okay, so this is the image before the dilation with the scale factor of 5/2, which is 2.5. So if AB is 2 units, just multiply that by 5/2, which is 2.5. Gets you 10/2, which is 5. So that means the dilation after a scale factor of 5/2 is going to then be at 5 units instead of 2 for AB. What's the center of dilation? Like I said, has to hit the points for everything, which it does for C. C is the center of dilation. And what is the scale factor? Well, it went from 1 to 3. So 1 times 3 is 3. That's the scale factor. Also, one more thing. Dilating triangles, right? These are super easy. Just count how far. I think it's another one I wanted to find. Hold on. Okay, yeah, these ones. Okay, so it tells you the scale factor is 2, and it tells you that the center of dilation is P. So count from point P, like C, for example, is 2 units down. Well, 2 times 2 is 4, so then it's going to be 4 units down. Point A is 3 to the right and 2 up. It will then be 6 to the right and 4 up. Point B is 1, 2, 3 to the right and 3 up. It's going to then be 6 to the right and 6 up. And that's how you dilate triangles. And remember, center of dilation has to hit both points. You can also tell 6.1 times 2 is 12.2. 5 times 2 is 10. 5.8 times 2 is about 11.7. So that's how you dilate these ones. Just count to see how far the point is and then multiply it by your scale factor. Okay, so let me know if you have any questions. Also know if you are ever confused and need videos kind of right away type thing when you're doing these, you can always watch the videos on Khan Academy as well. So when you're doing your homework on paper, it's the same thing. You're just doing it on paper. Reflections, translations, rotations. Let me know if you have any additional questions.